prime numbers, we have rational numbers, we have irrational numbers, and I would like to introduce you to real numbers and lastly complex numbers. So we have natural integers, involved, prime, rational, irrational, real and complex numbers. Let's start with the first one. So the first one is natural numbers. Natural numbers, there is a general symbol that we normally use to denote natural numbers, and that symbol is in form of letter N that is written here. So in form of N. And what are these natural numbers? There are no numbers that are new to us. That the numbers that we know right from when we were kids, like counting of numbers, 1, 2. So those numbers then are what we refer to as natural numbers. So it's not a new thing. So they are simply the counting numbers. And what are the counting numbers? 1, 2, 3, and so on. So I can simply say natural numbers. These are simply the counting numbers. These are simply the counting numbers. And as I've said, examples are 1, 2, 3, 4, 5, 6, and so on. And so on. So these are what we call natural numbers. Let's go to the next number, integers. Now, in case of integers, integers are whole numbers. Like all these kind of numbers we are seeing there, we call them whole numbers. But there are other numbers like decimal numbers, or you say fraction, numbers with decimal points. Integers, they are not decimal numbers, they are whole numbers. But in this case, we have two types of numbers. We have positive and negative numbers. So integers comprises both the positive and the negative whole numbers. They must be whole numbers. So all those positive and negative whole numbers are what we refer to as integers. So I can simply say these are both the negative and positive whole numbers. They are whole numbers. And what are the negative numbers? They are the numbers that always have minus sign at the back, just like we have -1, -2, and so on. In case of positive numbers, numbers are having positive sign, the plus sign at the back, like +2, +3, and so on like that. So meanwhile, most of the times they normally put positive sign at the front of positive number, just like this 1, 2, 3, 4. There are also positive numbers. They just don't put the positive sign there. So these are what we call positive numbers. And whenever you come across negative sign behind the number, you should know that refer to negative numbers. Now these integers are usually found on number line. And with the number line, you have the overview of all the numbers. So I would like to explain how number line looks like. It comprises all the numbers, and there's always a reference point that normally called 0. 0 is the reference point, and to the front we always have the positive numbers, and 0 backward we always have the negative numbers, just like that. Now all the numbers are seen here, they are whole numbers. But don't forget that between 1 and 2 we can have decimal numbers, though we are not moving to that now. We're only dealing with integers, so we'll only be considering the whole numbers. So as I've said, I said they are usually found on number line. And that's what I'm explaining now. All these whole numbers are seen on the number line. They are all integers. 0 is an integer. And have this in mind as well, that number always increases from the negative part to the positive part. Just like we have here now. From the reference point 0, you should know we have negative numbers backward, and it decreases backward like this. And from this reference point 0 to the front, you should know we have positive numbers, and it increases like this. So that shows that number increases from negative parts to the positive part. So you should have it in mind that this minus 3 you are seeing here is greater than minus 4. This minus 2 is greater than minus 3. Minus 1 greater than minus 2. 0 is greater than negative numbers. And 1 is greater than 0. That is, positive numbers are greater than 0. And it increases like that. 2 is greater than 2. 4 is greater than 3. And so on like that. So these are what we call integers. And these are the examples. Let's list out the examples of integers. So starting from 0, then you can just say plus or minus 1, plus or minus 2, plus or minus 3, and so on like that. But have it in mind, just like the way we have natural numbers being represented by this general symbol, we also have integers symbols. The general symbol for integers is always in form of letter Z. If you can manage this side, it's always in form of letter Z. Then you put a line like that. So whenever you come across this symbol like this in form of letter Z, you should know that referring to integers. So the next kinds of number we'll be considering should be even numbers. So what are even numbers? Even numbers are numbers that can be divided by 2 exactly. Because if you just say there are numbers that can be divided by 2, there are various numbers that 2 can divide. 2 can divide 3, 2 can divide 5. So whenever 2 divide a particular number and there is no remainder, then you can say that number is an even number. So you can simply say even numbers are numbers that can be divided by 2 exactly. You can simply say that. Or numbers that 2 can divide without any remainder. So I will simply say here that even numbers, these are numbers that can be divided by 2 exactly. By 2 exactly, showing that 2 can divide that particular number without any remainder. And what are all these numbers? So examples, numbers that 2 can divide exactly without any remainder. That shows that 2 itself can divide itself without any remainder. 2 in 2. If 2 should divide 2, is always 1. So you should know 2 is an even number. 3. If 2 should divide 3, there will be remainder. 2 goes in 3. If you can't, just like on my own now. 1, 2, 3. Remove 2. So it will remain 1. So 2 in 3 is 1. Remainder 1. So you should know 3 can never be even numbers. It's only numbers that 2 can divide exactly. And you realize that the next one should be 4. Next one should be 6. Next one should be 8. Next one will be 10, 12. And so on like that. One simple logic about even numbers is that numbers that ends with the following digits 0, 2, 4, 6, and 8 should have it in mind that they are always even numbers. What I say, let's write it. It should be noted. It should be noted that numbers that end with the following digits are always even numbers. And what are the digits? We have 0, 2, 4, 6, and 8. So numbers that end with 0, 2, 4, 6, and 8, you should know that they are always even numbers. So if I should give you larger numbers like 102, seeing 2, you should know 100, 1004, seeing 4, 1008, seeing 8. So numbers that end with 0, 2, 4, 6, and 8, you should know they are even numbers. So that is just the secret. So the next number we'll be considering, should be odd numbers. Odd numbers. It's more or less like opposite of even numbers. In case of even numbers, as I've said, I said number that you can divide exactly. And I mean saying exactly, I mean numbers that you can divide without any remainder. So even from there, you can even say numbers that can divide by 2 without any remainder, you are correct. In case of odd numbers now, the reverse is the case. Odd numbers, there are numbers that 2 cannot divide exactly. Even if 2 should divide, it will have remainder. That's what it means. So numbers that cannot be divided by 2 exactly, they are odd or numbers. So these are numbers that cannot be divided by 2 exactly. What are the examples of all these numbers? Starting from 1. So 1 is an odd number because 2 cannot divide 1 exactly. So the next one should be 3, the next one should be 5. If 2 should divide 5, you have remainder. So 5 is an odd number. 7, 9, 11, 13, and so on like that. So numbers that 2 cannot divide exactly are all referred to as odd numbers. So just like we have in even numbers, that there is simple way you can easily identify even numbers. Similarly, there are simple ways that you can identify odd numbers. So in case of odd numbers, it should be noted that numbers that ends with 1, 3, 5, 7, and 9 are odd numbers. So it should be noted that numbers that ends with 1, 3, 5, 7, and 9, that they are odd numbers. Just in case of people that ends with 0, 2, 4, 6, and 8. So whenever you come across number that ends with 1, either 1, 3, 5, 7, and 9, then you can say they are odd numbers. So if I should give you larger numbers like 101, you should know since it ends with 1 is an odd number and 2 cannot divide it exactly. So if I should write 115, 115, since it ends with 5, you should know 2 cannot divide it exactly. So numbers that end with 1, 3, 5, 7, and 9, they are always odd numbers. So we can simply derive that all odd numbers can never be even numbers, and all even numbers can never be odd. So even always end with 0, 2, 4, 6, 8, and the remaining digits. You know we have 10 digits: 0, 1, 2, 3, 4, 5, 6 to 9. So 0, 2, 4, 6, 8 belongs to even, and the remaining 1, 3, 5, 7, 9 belongs to odd. So there is no case that an odd numbers can also be even number. So just have that in mind. So let's move to the next number, which is the prime numbers. Now, what are prime numbers? These are numbers that can only be divided by 1 and itself. Prime numbers have been one of the major problems to basic learners, but there is not a big deal there when it comes to prime numbers. Now, as I've said, numbers that can only be divided by what? 1 and itself. That is, 1 can divide the number and the number itself can divide the number. So any other number cannot divide it. So whenever you come across a number, there is only 1 and that number itself that can divide the number, then you should know that number is a prime number. In other words, you can say prime numbers, you can say they are numbers that possess only two factors, which are 1 and itself. So if they want to go by this definition, you can go by this, by saying there are numbers that possess only two factors. And what are the two factors? 1 and itself. But this is why I'm giving you this definition is for you to be able to get what prime numbers are easily using factor method. What are the examples of prime numbers? So the first prime number we have is 2. You'll be wondering that how come the first prime number is 2? Why is 1 not there? Chill. I will tell you the reason why 1 is not a prime number. So the first prime number that we have is 2. So the next one is 3. The next one is 5. The next one is 7. I would like you to pay attention at this corner because there are many numbers that we neglected here. And to you, in some cases, you might have listed some numbers already that are not included from this my first 5 prime numbers listed there. Now, the first problem we have, to some they believe 1 is a prime number. No, 1 is not a prime number. The first prime number we have is 2, and the next one is 3. You can even check. When considering 2, you can see that there is only 1 and 2 itself that can divide 2. If you have 2, it's only 1 that can divide 2, that will be 2, and it's only 2 itself that can divide 2, which is 1. There is no any other number that can divide 2. Check 3. It's only 1 that can divide 3 exactly. It's only 3 itself that can divide 3 exactly like that. So there is no any other number that can divide 3 exactly. Now, the next number here should be 4, but check 4. 4. If 1 should divide 4, it's not only 4 itself that can divide 4. You can see that 2 as well can divide 4 to be 2. Do you get that now? And the instruction says prime numbers can only possess how many factors? 2 factors. And what are the 2 factors? 1 and another number itself. So in case of 4 now, you can see 1 will divide 4, 2 will divide 4, 4 itself will divide 4. You can see that now. So that shows that 1, 2, and 4 are factors of 4. 1, 2, and 4. You can see it's even more than 2 factors, which is not a prime number. So 4 can never be prime number. So the next prime number we have should be 5. So you check that it will be 1 and 5 that can divide 5. 7, 1 and 7 that can divide 7 exactly. 11, 1 and 11. Take note, 9 is not a prime number. 9 is not a prime number. Now, I said earlier that some cases normally included 1 as a prime number is very, very wrong. And why is 1 not a prime number? 1 is not a prime number because it only has 1 factor, which is 1 itself. But before a number can be prime, don't forget I said it must possess what? 2 factors. So 1 and 1 itself, can you see it's still 1? So it's only 1 factor that is having. So you should have it in mind that 1 can never be prime number. So take notes. Note, 1 is not a prime number because it only has 1 factor. 1 factor. So 1 is not a prime number because it only has 1 factor. So just have that in mind. So don't be confused to put in odd numbers into prime numbers. Always check that it's only 1 and that number that can divide itself. Once other numbers can divide, just like 9, now you can see that 3 can divide. You should know it's not a prime number. Don't worry, there's some basic topics we are going to consider, which include factors. So when we get there, even having knowledge of finding factors of numbers, you should be able to know the numbers that should belong to prime numbers. Even with this explanation, just try to make yourself comfortable and don't be confused. And make sure that you always check that it's only having 2 factors, which is only 1 and itself. Once there are other factors that can divide that number, you should know that number can never be prime. So let's move to the next number. Number 6. And what is the rational numbers? Rational numbers. Rational numbers.